Okay, now let's look at applying caret functionality to nnet method. All right, so we specify a tuning grid or the different values that you want to consider, and we'll call this my grid, my dot grid, and the function we use to set up the grid is expand grid. Now we can specify the parameters. So there are two for nnet, and that is one is decay. We say dot decay equal to, and what are the different values for decay that you want. Okay, so here let's say 0.5 and 0.1. So those are the two values for decay we're going to consider. And then the second parameter is the number of neurons in the hidden layer, and that is equal to size. So then we can specify what are the sizes that we want. Say we want 5, 6, and 7. So 5 to 7. Okay, if you run that, so now my grid gets set up. So if you look at my grid, you see different decay values. There are 0.5 and 0.1, and the size is 5, 6, and 7. So you get a grid matrix. Tuning values of grid tuning values are set up as a grid matrix, right? So then we use the train. Let's call this nn.cr, and we use the caret procedure train. All right, and here we specify the formula: salt plus fat, and then data equal to df. Okay, and method equal to nnet. Okay, within quotation mark. Okay, now neural net will not work here because neural net caret uses neural net only for interval target. Okay, now then you can specify the tuning grid, tune grid equal to my grid, and then trace equal to false. Okay, run that. And then we will set up the weights and run the plot. Okay, copy paste that part. Okay, but now since we have NNCR. Okay, NNCR is the result of caret, and in caret the weights are not in the NN, the object itself. Okay, because there is you have the final model for the object. Okay, final model, and inside the final model we have the weight and the n. So it's not the object dollar weights, but object dollar. So we here again we have CR final model and then n. Okay, and then the rest of them are the same. So now if you run that set, you'll get the best model. So here we ran 0.5 and 0.1 decay, and then 5, 6, and 7. Of those 5, 6, and 7, the best model is with 5 neurons in the hidden layer. And you get the predicted probability, okay, using, so if you want probabilities, then you get predict nn.cr, right? New data is df. And then you get the CR probabilities. We have to specify type equal to prob. Then we get the probabilities. CR.prob, like and dislike.